All right, welcome to an exciting time in chemistry where we start our investigation of stoichiometry, which we'll get there. But first, we have to deal with the mole and molar mass. And when we're talking about a mole, if you Google mole, you'll find lots of different little pictures. You'll find this guy; he's called a mole, but that's not the one we're talking about. You'll find this; that's a mole. But that's not the right kind of mole either. You'll find this yummy deliciousness here, mole, but that's not what we're talking about. He's pretty cute right here, but again, that's not what we're talking about. The mole that we're talking about in chemistry is represented as this. Right here in the middle, we've got this thing called Mole Island, and I'll tell you what a mole is, and we'll figure out what this island thing is, and hopefully it's not too difficult. So let's get started. Our first question is, what is the mole when we're dealing with it in chemistry? The mole is basically nothing more than just what we call a counting unit. So just like a dozen is equal to 12. If you buy a case of soda, there's going to be 24. If you have a pair of socks, that means you have 2. Well, if you have a mole of something, okay, that means you have 6.02 times 10 to the 23rd of something, okay? And in chemistry, we're going to be dealing with atoms and molecules. So 1 mole is 6.02 times 10 to the 23rd atoms or molecules. Now, this is what we call Avogadro's number, because this freaky guy right here, he came up with this number of atoms based on, I think, the carbon atom. So 6.02 times 10 to the 23rd, that is his number. So call him maybe. All right. All right, so why do we use the mole? Chemists use the mole when calculating the atomic masses of an element. So I have a little confession to make. Last semester when I was teaching you all about the periodic table, and I told you that this number in a decimal number there was the average atomic mass. Well, it's not. It's not the atomic mass, because if you think about it, an atom, for example, of nitrogen weighs 14 grams. That doesn't make much sense. We can't even see an atom. So how could it weigh 14 grams? So here's my confession. It's not the average atomic mass. It's actually the average molar mass, because that is the mass of 1 mole of atoms. Okay, so 6.02 times 10 to the 23rd nitrogen atoms weighs 14 grams. Not just one. Okay, not one atom. So there's my confession. I'm sorry. Okay. All right, let's move on. Our second question deals with this molar mass. So we're going to define molar mass. And basically molar mass is the mass of 1 mole of a substance. Okay, we measure this in the units grams per mole. And no, I didn't forget the E on mole. That's how you abbreviate it. Wow, you take off the E and it's the abbreviation for mole. Yeah. Anyway, so let's see how this works. Let's say we wanted to figure out the molar mass of, let's say, AS, arsenic. Okay, so we take a look at the periodic table. Here's arsenic. All right, if we look at the decimal number, it's 74.9. So we can say that arsenic, his molar mass is, well, we'll round it, 75.0 grams per mole. Okay. It's as easy as that, just looking on the periodic table at that decimal number. So again, let's pick PB, lead, down here. So we take a look at that decimal number, and the molar mass of PB is 207 grams per mole. Okay, it's as easy as that. Now let's get a hair a little more complicated. What if we want to figure out the molar mass of nitrogen gas? Now remember, nitrogen gas is part of Hofbrinkel, so he's N2. So guess what do? All right, we take a look at N, each N is 14 grams per mole. And if we have two N's here, because we have that subscript 2, then we just multiply it by 2. So 14 times 2, 28 grams per mole. Okay. How about if we have a molecule? How about if we do water, for example? Okay, let's take a look at water. H2O. So let's figure out the molar mass of H2O. So let's say we've got H's. Okay, each H is worth 1. Okay, so if we have 2 H's, that's 2. And then we have oxygen here. Oxygen is 15.99999. We'll call it 16. So we have 1 oxygen, which is 16, plus 2 hydrogens, okay, which is 2. So 16 plus 2, 18 grams per mole. Okay, so that's how it works. If you have this big, huge molecule, you're just going to add up how many of each, the weight of how many of each atom in that molecule, and that's going to be your molar mass of the molecule. So it's pretty simple once you take it from the periodic table. All right, so let's see how this gets a little bit more complicated when we have to talk about converting between grams and moles. Our last question of these notes deals with converting between grams, moles, and atoms or molecules. Because in chemistry, when we do chemical reactions, we write them out, and we'll see that the coefficients are actually going to tell us the number of moles that are taking place in the chemical reaction. However, if you take a look at the scale, right, the scale doesn't measure in moles. Scales measure in grams. So in chemistry, we weigh out substances in grams, but when we're talking about them in chemical reactions, we need to talk about them as moles. So we're going to have to be able to convert between them. And so that's where this fancy-dancy dun 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 mole island is going to help us. Okay, so this is a schematic that I found online. I usually like to draw something a little simpler. So let's take a look and really focus on Mole Island and what it is. Basically, it's a chain of islands. Pretend, obviously, in chemistry land. It's pretend, okay, that are interlinked with each other. And you have, in chemistry, we're going to be kind of traveling from Graham Island, maybe, to Mole Island, or maybe from atoms to moles, okay? So kind of back and forth. These are our conversions that we can actually do. We can convert between grams and moles, or maybe we need to figure out how many atoms are in a mole, or perhaps if we're given the number of grams and they want us to figure out how many atoms there are, we can do that too. So this kind of is going to help us figure out how to convert between all 3 of those things. Now, Liter Island we'll get to, but we're not going to deal with it right now, so I don't want to throw too many things in to confuse you. But let's take a look at how Mole Island conversions work. Okay, so here's my simplified version of Mole Island. So we've got the 3 main islands. We've got Graham Island, Mole Island, and Atoms or Molecules Island. And in between them, we have bridges. Because guess what we get to do? More bridges! I know you're super excited. Okay, so we have to do bridge calculations in order to go from grams to moles, moles to molecules, or even grams over to atoms. So this is how it's going to work. I'm going to give you a few little rules, and then we're going to go over a couple of examples together. All right, so in this schematic, the number of bridges you need to cross to get from one unit or island to the next. So for example, if you want to go from grams to moles, you just cross 1 bridge. Or if you want to go all the way, if you have to convert from grams all the way to atoms, you have to cross 2 bridges, because you see that there's actually not one bridge that goes straight from grams to atoms. So the number of bridges you need to cross tells you the number of bridge calculations you're going to make in your calculation. So we have bridges, and so when we have bridges, we have to have those conversion factors. And here are the 2 big conversion factors we're going to deal with in this concept. So remember, 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. So if we're going from moles to atoms, we're going to use that conversion factor with 1 mole equals 6.02 times 10 to the 23 atoms. However, if we're going to, if we're making a conversion between grams and moles, we're going to use the second one, which is 1 mole equals however many grams you see on the periodic table for that element. So this is one you're going to have to look up on your periodic table. So look on PT. Okay, it's the decimal number on your periodic table. All right, so let's keep that in mind. And if it's still confusing, we're going to go over a couple of examples. So hopefully you guys can get it. So here's our first example. How many moles of Fe, or iron, are in 111.8 grams of iron? Okay, so working with iron here, we need to know how many moles do you have if you have 111.8 grams sitting in front of you. So if we take a look at our mole island schematic, we are going from gram island over here to mole island right here. So you ask yourself, how many bridges do we cross? We only cross 1 bridge. So that means when we are setting up our bridge calculations, we are only going to have 1 bridge. Okay, just like that. All right. So just like in previous bridge calculations that I taught you guys last semester, you always start with what you're given. So for this example, in our sample problem, we are given 111.8 grams of iron. So that's exactly what we start with on that left side of our bridge. Okay, is 111.8 grams of iron. And please get in the habit of putting down the atoms or molecules you're working with, because if you don't, you'll get confused. Guaranteed. Just going to leave it at that. All right, so just like in what I taught you last semester, we start with what we're given on the other side of our bridge, because we're going to walk across this bridge to the other island. And in this case, it's moles. So we're going to go over to moles of Fe, because that's the unit where you want to go. So again, we're going to write the unit of where we end or where we want to go on the top right-hand side. Now, in order to cancel out our grams, because we can't take, when we cross the bridge, in essence, we have to dump our luggage, dump our units. We have to cancel these gram units by putting them down here on the bottom right-hand side. So because we have grams of Fe over here on the top left, we must have grams of Fe on the bottom right. So write the original unit on the bottom so we can cancel it. Now once we have the units set up, then you put in your numbers. I will gonna say this a million times. I know it already. You must put your units first, then plug in the numbers. Don't do numbers before units. Units before numbers. Okay? All right, so let's take a look at what we need. In this bridge here, we have moles and grams. So that means that we need to look on our periodic table for how many grams are in 1 mole for iron. So we see here's our iron from our periodic table. Okay, and we can see that there are 55.8 grams per mole. So we're going to put that number. The 55 is the grams, so it goes on the bottom. Okay, so 55.8 grams per mole. And that's in, it's grams per mole. So that's in 1 mole. So 1 goes on top with the mole, and 55.8 goes on the bottom with grams, because 1 mole of iron equals 55.58 grams. We got that from our periodic table. So our last step here is to just calculate. And remember, with our bridges, we multiply everything on top and we divide by what's on the bottom. So we're going to do 111.8 times 1, which is 111.8, divided by 55.8. And that's going to give us about 2.00 moles of iron. So if you have 111.8 grams of iron sitting there, what you're looking at is 2 moles of it. Okay, so that's how we do that. So please, 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 please make sure that you write everything down on this. Okay, write this down on your in your notebooks. All right, I won't give a stamp if you don't have this written down, just flat out, because I know some of you just like to write what's typed and don't write what's drawn, but this time you have to write all this stuff down. Okay, let's take a look at one more example where instead of just going over one bridge, we have to cross 2 bridges. We're going to go from grams all the way over to atoms. So let's take a look. Okay, so here's our last example that we're going to do in these notes. This one says how many atoms are in 111.8 grams of iron. Okay, so this time we're going from grams to atoms. We're starting with grams because that's what we're given. And then we're going to go, so we're starting with grams because that's what we're given, and we have to go all the way over to atoms because that's what it asks for. Now, when we do this, we see that there's not just a single bridge that goes from grams to atoms. You have to go through moles first. So that means you have to cross 2 bridges. So in our schematic, we cross 2 bridges. That means in our calculations, we draw 2 bridges. Okay, 1, and we draw them right next to each other. 2. Okay, so this is how it works. Again, we start with what we're given, 111.8 grams of iron. Right? So here's our starting point. To get over to atoms, we have to go to moles first. So that means our moles of iron go right here, because we're going to cross this first bridge, go from grams to moles. Remember, when we cross that bridge, we have to get rid of our units. So we're going to put our grams of Fe on the bottom so that they will cancel. All right, and now to cross the now we have to cross the second bridge to get to atoms. So we're going to go from moles here, okay, to atoms of Fe over here. So again, when we cross this bridge, then we have to cancel our mole units this time by putting them down there on the bottom of our second bridge. So that's how it works. We're going to be going from grams to moles, moles to atoms. So again, must do units first before you plug in the numbers. We have our units set out. Now we can look at our units to figure out what conversion factor numbers go there. So the first conversion factor right here is between moles and grams. So that means if we have a moles and grams, we have to look where? On our periodic table. So let's look at iron. Okay, so here's iron on our periodic table, and our decimal number is, again, 55.9. Okay, so 55.9 is the grams, and that is equal to 1 mole because it's 55.9 grams per mole. So 1 mole equals 55.9 grams. So that's our first conversion factor. Now we have to look at the next bridge units for our second conversion factor. Our second conversion factor has to deal with atoms and moles. Okay, so that's Avogadro's number. In 1 mole, there are 6.02 times 10 to the 23rd atoms. Okay, that one we don't have to look up on our periodic table. That one we know from Avogadro's number, who says 1 mole is equal to 6.02 times 10 to the 23rd atoms. All right, so now here's where you have to have a scientific calculator handy, okay, because we are dealing with exponent numbers. So we've got everything filled in. Now we have to do our math. We're going to do 111.8 times 1 times 6.02 times 10 to the 23rd. When you put this in your calculator, always, always, always put this gigantic numbers in parentheses. Okay, so your calculator knows to keep it together and not separate it, when it's dividing or anything like that. Okay, so put your Avogadro number always in parentheses in your calculator. All right, so you'll punch that in, you get the number, and then you can divide by what's on the bottom, 55.9 times 1, so 55.9. When we do that, we end up with an answer of 1.20 times 10 to the 24th atoms of Fe. So that's how many atoms are in 111.8 grams of iron. So if you measured out 111.8 grams of little iron dust, like we've worked with before, you'll be looking at 1.2 times 10 to the 24th atoms. I know that's mind-blowing. I just blew your mind right there, but that's how we do that. Okay? So tomorrow we're going to do a bunch more practice problems with this. And so please make sure you draw the mole island thing on your papers. It's really, easy, good schematic to keep in mind when we're doing these conversions. All right, so I will see you tomorrow.